Hello, Math 175. In this video, I'm going to be showing you the solutions to problem 19 and problem number 20 on the sample final. Unfortunately, the previous video that I had for this, the file was corrupted, so I have to redo it. No big deal, I'll do it for you guys. All right, so problem number 19 states, evaluate the derivative f prime of x of the function f of x defined by the following integral, right? It's the definite integral from 0 to x of 1 over the square root of 1 plus t to the third dt. So essentially what you want to do here, you want to find f prime of x by using the second fundamental theorem of calculus. So informally, when you take the derivative of your integral, you're plugging in your upper limit of integration, which is x, this variable, for wherever you see a t, right? So f prime of x is going to equal to, if you take the derivative with respect to x of this given integral from 0 to x of 1 over the square root of 1 plus t to the third dt. Informally, the derivative gets rid of the integral, and you're replacing wherever you see the t with an x, right? So the x replaces the t here. So what you're going to get is 1 over the square root of 1 plus x cubed. So that is your derivative, f prime of x. It's 1 over, again, square root of 1 plus x cubed. Now, the problem asks you to evaluate this derivative at x equals 2. So what you have to compute now is f prime of 2. So wherever you see an x, you replace the x with 2. So you're going to get 1 over the square root of 1 plus 2 to the third power. So 2 to the third is 8. 8 plus 1 is 9. So you have 1 divided by the square root of 9. If you take the square root of 9, you get 3. So your final answer is that f prime of 2 is 1 over 3. And that is the solution to problem number 19. Now I'll continue where I do the solution to problem number 20, the final problem on the sample final. So it states, evaluate the indefinite integral x times sine of x squared dx. In order for us to evaluate this integral, unfortunately, I cannot separate this into 2 or more integrals because the fact that there's no plus or minus sign between the x and the sine squared of sine of x squared. But in order for me to solve this problem, essentially, I need to use the u substitution method for integration. Substitution for integration. Basically, I have to define my u, figure out what's du, and then I'm going to change the variables. Instead of integrating this with respect to x, I'm going to integrate it with respect to u, because it will be much easier to integrate this function with respect to u rather than x. So your u should typically be some sort of inner function. The inner function in this case would have been x squared. So you want to let u equals to x squared. Now, if you take the derivative, right, if you try to find du, it's the derivative of x squared times dx. So the derivative of x squared is 2x dx. Now, unfortunately, inside of my integral, I have x dx. I don't have 2x dx. So before I can make some sort of substitution or some sort of replacement there, I need to divide both sides of this equation, this du equals 2x dx, by 2. Now, if you divide both sides of the equation by 2, it's the same thing as saying that you're multiplying by positive 1/2, right? So if I multiply by 1/2 on both sides, then the 1/2 and my 2 on the right-hand side of the equation gets canceled, and we're going to have 1/2 du is equal to x dx. So the x dx inside of the integral now gets replaced with 1/2 du, and the x squared gets replaced with a gets replaced by u. Now, another thing that we can do when we rewrite this integral is that the 1/2, that constant multiple, I can push it outside of the integral, right? So in other words, the 1/2, we can stick it right in front of the integral sign. So when we rewrite this original integral, when we take this integral in terms of x and rewrite it in terms of u, we're now going to have 1/2, right? You can pull the constant multiple out on the outside, 1/2 times the integral of, now, let's see, the x squared gets replaced with u, so we're going to have sine of u times du, right? The du replaces the x dx. And again, the 1/2 was on the outside. Okay, now if you look at this integral on the right, 1/2 times the integral of sine u du, this is much more easier to integrate than what we had originally. We know that the antiderivative of sine of u is negative cosine of u. So we will have the following answer. We have 1/2 times the antiderivative of sine of u, which is negative cosine of u, plus our arbitrary constant, which is c. And you replace the u now with what we had originally, right? We write u in terms of x, which was x squared. So the way that you can write out your final answer is negative, right? 1 times negative cosine of u, or 1 times negative cosine of x squared, divided by 2, plus your arbitrary constant c. And that would have been your final answer. You could have checked that this answer is true by taking the derivative of our final answer. If you take its derivative, you should get exactly what's inside our integral, the x times sine x squared, right? So here's just a quick check, so that way I can just verify that this answer is true. So if I take the derivative with respect to x of negative cosine x squared over 2 plus c, notice that the first term, negative cosine x squared over 2, I would technically have to use a chain rule there. The derivative of c, that would have just been 0, so that goes away. So I need to make a u substitution, right, when I do a chain rule. So we can let u equals to the x squared. So if I take the derivative with respect to x of negative cosine of u divided by 2, what we're going to get is the following. The derivative of cosine of u would have been negative sine of u. So we have negative of negative sine of u over 2 times the derivative of your inner function, which will be u prime. So if we know that u is equal to x squared, then that implies that u prime is 2x. So if I make back my substitution here and just rewrite this, negative of negative sine of u would have now become positive sine of u, or just positive sine x squared, right, in terms of x, over 2 times u prime, which is 2x. So if you have sine x squared times 2x over 2, the 2's will cancel. And what you're going to have remaining is just x times sine of x squared. And if you notice, this is exactly what's inside of the integral. It was x times sine of x squared. And that's your final solution. Well, that was just a check that our final solution of negative cosine x squared over 2 plus c is valid. And that's it.